All right, before we get any further along, I want to make a couple of announcements. If you haven't already done so, please go into the announcements for this class and read it. There's a doodle poll on there that will have to do with the exam that we will end up having. I have 8 different time slots available for you to end up having possibility of having your exam. I want to know what people can end up doing, so please get on there as soon as possible. The block would be from Friday through Monday, and part of the reason for that is that I want to be able to go over stuff next week with you. If you have questions on anything looking toward either the lab final or to the lecture final, so that you can start asking questions and we can end up addressing those. And that I also will need to know if the regular lab time, if you're able to end up taking the lab final. There are a couple people who don't have the lab, but if you've got the lab, if you're not able to be there next week on the 22nd at the normal lab time, let me know, and we'll end up trying to work something out so that we'll be able to do that. Otherwise, the lab final will be during the regular period. Same deal, going a little further ahead, that I want you to check to see whether the official time we have for the lecture final exam, if you're able to end up taking a final exam during that period. If not, you please also let me know. There's a little bit more time between now and then, but do let me know so I can try to work with you. The exam itself, the lecture third exam, will be done on sapling learning. So you'll end up having basically questions that are taken from sapling learning. They're not the ones we've done, but are that are provided by sapling. I'll have probably 8 questions there. Each of them will be equally weighted. So, all right. So now that we've gotten sort of some of this background stuff out of the way, we'll continue talking about rotational motion, and that we already addressed a little bit kinetic energy of rotation whenever we introduced the concept of moment of inertia. We're going to end up coming back to it and combining it with what we said at the end of the last lecture period, that if you've got something that's rolling without slip, that it's going to end up having translational kinetic energy and rotational kinetic energy simultaneously and separably. So to calculate what your kinetic energy is for that system, it'll be the sum of the kinetic energy due to the translational motion and the kinetic energy due to the rotational motion. In this sort of situation, we can do some of the same types of calculations we would have done in previous things where we did conservation of energy. But bearing in mind that if you're rolling without slip, then the kinetic energy term will look different. It's not going to be 1/2 mv squared anymore. That's one of the reasons why back when we did all these things with objects moving on ramps and whatever like that, it may have been bizarre to you. It's like, okay, if I'm wanting something to go up a ramp, I want it to be on wheels, right? The reason why we don't is that there's this extra complication that comes into play. All right, so I gave an example of a ramp. The end of the ramp would be 4 meters above the low point. It ends up coming down to the lowest point, goes up a bump, then comes back down, where the final height is a meter higher than the lowest point. We'll assume that the ball doesn't fly off of the ramp at any point. So if it ends up rolling without slip down there, we can end up calculating what your final speed is. And in order to do so, we'll use conservation of energy. Your change in kinetic plus gravitational potential energy is always going to be equal to the sum of your external and non-conservative work. The normal force work just like last time we did it, is going to be 0 for the same reason. The surface isn't moving, so if it slides across the surface, your velocity is always perpendicular to the normal force. So, and remember, the dot product then will end up giving you a power of 0. So if the power is 0 all the way through, so is the work. And as far as your friction work goes, friction only acts in this situation to the degree that's necessary to cause it to roll without slip. Because if there's no friction literally whatsoever, it will skid. But we're assuming that we have just barely enough friction to end up causing it to roll without slip, and otherwise there's no, so we're not losing energy due to friction in that process. So then the non-conservative work is all 0. So we just use conservation of energy, and we'll do then final minus initial kinetic energy plus final minus initial gravitational potential energy will equal 0. So to calculate your kinetic energy, it would be the kinetic energy of the linear motion plus the kinetic energy of the rotational motion. Now I had made the assumption here that our ball that's rolling is a hollow sphere. So from the list of moments of inertia in the moment of inertia table, you'll end up seeing that the moment of inertia for that will be 2/3 the mass times the radius of the sphere squared. So I end up taking my kinetic energy as my linear one, which is 1/2 mv squared, plus 1/2 my moment of inertia times angular velocity squared. I clean that up, combine terms together, do a little bit of common denominator, and I get 5/6 mv squared as being my total kinetic energy for it. So then now I do the same kind of things I've done previously. You can choose your height of 0 for gravitational potential energy wherever you want, just like we did before. I went there with the one that a lot of times the students wanted to do was at the lowest point. It's not necessarily even the best choice, but it is one of them. So if we do that, then my final height was 1 meter higher than the lowest point. My initial was 4 meters above the lowest point. So I ended up using those to find my gravitational potential energy initial and final. I actually gave you, I think, the mass of the ball, but it didn't matter because the masses cancel out. And then I went through and solved and found 5.94 meters per second as being your kinetic energy, being your final speed, excuse me. Right, and I think we'll do rotational work in the next.